Welcome to Lecture Online, and now let's have a demonstration of what a gyroscope can do. As you saw in the previous videos, the gyroscope, which is basically a spinning disc, this is a very heavy metal spinning disc. Once it's spinning fast, it creates a very large angular momentum, and then when I place this gyroscope on the stand right here, it will cause a torque. The torque will then cause the angular momentum to change, and the changing angular momentum will then cause what we call a precessional rotation or precessional velocity. So let's take a look at this. It will appear as if the gyroscope defies gravity. Let's try it. And what I need here, first I need to get it spinning. That's what this almost looks like a shoe polisher will accomplish. And let's see there. I want to make sure I got this in the right direction. Makes a little bit of noise, so hang in there with me. All right, so we got that spinning. And there we have it. There's a gyroscope in action. So what's happening now is, because of this very fast spinning motion, if you follow the right-hand rule, if you turn your fingers in the direction of the spinning disc and it's spinning in this direction, there will be an angular momentum vector pointing out this way. By placing it on the stand, there's a torque that causes it to push. The torque causes the gyroscope to be pushed in this direction, which causes that change in the angular momentum. As you will see over time, the gyroscope will rotate faster and faster and faster because the torque causes an acceleration in this particular direction. So you can see that as time goes by, the gyroscope will just spin faster, 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 and will also begin to orient at a greater and greater angle relative to the horizontal. This is just quite amazing. If you imagine here that the weight of the gyroscope should be pushing this down, it's only being supported by this central point right here on this stand. And as you can see that it's beginning to spin faster and faster and faster as the angular momentum is changing, and also it's beginning to orient itself at a steeper and steeper angle. So that second, the rise of the gyroscope is caused by, again, if you follow your right-hand rule, if you turn your fingers in the direction of the spinning gyroscope, you can see that the angular momentum is in this direction. Now, as it's spinning faster and faster and faster, the angular momentum then is, of course, increasing, and it needs to find a way to decrease that, to offset it, because angular momentum is always conserved. The way you can do that is by changing the angular radius, or I should say the radius of motion, of angular motion. If that radius can be shortened, it compensates for that. So you can see that it's almost standing completely up now. Quite amazing. So let me show it one more time. Whoa, I got to be careful here. Let me show this one more time, and this time I'll put it at a slightly different angle so you can see a little bit different motion. And there we go, so it's not quite as steep of an angle. Again, it appears to be defying gravity. It starts spinning very slow, and after time it'll just start picking up speed. It's quite an amazing thing to be looking at that. Now also notice that gyroscopes are used in satellites, in airplane, in missiles, anything that needs to keep very accurate track of where they are and what direction they're traveling. A gyroscope actually is able to, or if you put sensors around a gyroscope, you're actually able to detect the forces acting on the gyroscope. When you cause the gyroscope to change direction or change angle, it applies a force, and that force can then be detected, and that detection of that force enables satellites and missiles and airplanes and things like that to detect what direction they're flying, what direction they're changing, and then compensate for that. So it's actually used in all kinds of navigation purposes as well. But for now, this is just a toy for demonstration. It's actually a lot of fun to just look at it. I somehow can never get tired of seeing this thing spin around like that. And notice again that slowly it's beginning to pick up more and more speed. Notice that if you point your fingers in the direction of the precessional motion, we have an angular momentum vector going in this direction, and as it's spinning faster and faster and faster, that would be the violation of conservation of angular momentum. It compensates for that by making the radius arm smaller and smaller and smaller, so that the angular momentum remains constant in the vertical direction, And then of course we have the angular momentum also pointing this way from the spinning disc itself. So there's actually two types of angular momentum going on right here, one for the spinning disc and one for the whole gyroscope rotating around. So you can see that it just keeps on going faster and faster and faster, and the radius arm has to change to compensate for the increase in angular momentum in the vertical direction. And let me grab that off there. Now, another interesting thing is, which of course you can't see there in the camera, is that when I start changing the direction of spin, I can really feel a lot of force. It takes a lot of strength to keep this from falling out of my hands, because it wants to kind of jump out of my hands. So anytime I make a sudden change like that, I feel a very strong force, because what I'm trying to do here is change the angular momentum. When you do that, you need a force or a torque to do that. Unfortunately, you can't feel that. If you ever have a chance to grab one of these things and kind of play with it, it's really strange how these seemingly unworldly forces act on you as you try to turn the gyroscope around like that. That's a nice illustration of what a gyroscope can do and how a gyroscope works.